When you've learned about the electrical energy between charged particles and how different materials move charged particles. Now, click on Forms of Electricity to see how electrons move between objects and across varying distances. Sometimes, when you walk across the carpet and reach for the door or light switch, you receive a little shock. You may have also used a battery-operated device, such as a radio or flashlight. Both of these instances are examples of electricity, but they show the two different forms that electrical energy can take: static electricity and electric current. Next, you will learn how charged particles can jump between objects in static electricity or flow steadily through conducting material in electric currents. You have probably had experience with static electricity. In dry weather, sometimes your hair may stick to your sweater or jacket. You may have noticed that the pages of a magazine sometimes stick together, or when your clothes come out of the dryer, they sometimes stick together. Even lightning during a storm involves static electricity. Static electricity is the buildup of excess charges on an object. The buildup of charges occurs when an object that holds its electrons tightly is in contact with an object that does not hold its electrons tightly. The loosely held electrons are transferred to the surface of the object with tightly held electrons. When you walk across the carpet, some of the atoms in your shoes hold their electrons more tightly than the atoms of the carpet hold their electrons. So the electrons rub off the carpet onto your shoes and to you, giving you a slightly negative charge. Because you carry a charge, you have the potential to conduct electricity, but the negative charges do not have a positive charge to move toward. The charges don't move, so this type of electricity is known as static. Knowing that static means stationary may help you remember static electricity. So how come you feel the shock when you touch metal, like a doorknob? When you reach out to touch the doorknob, the electrons covering your skin follow the law of electric charge. They force negative charges on the doorknob away from the surface, leaving the positive charges at the surface. When your hand gets close enough to the doorknob, the attraction of the positive charges on the doorknob pulls the excess electrons from your skin. This sudden movement of charge from your hand to the doorknob causes the shock and sometimes a spark. The sudden movement of electrons from one object to another is called an electric discharge. Lightning is a result of static electricity buildup in clouds. The water and air currents in storm clouds cause a buildup of negative charges on the bottom of the clouds. The negative charge on the bottom of clouds forces the ground to become positively charged, because negative charges of the clouds push the electrons further into the ground. When the negative charge on the bottom of the cloud becomes strong enough, the positively charged ground pulls the electrons from the cloud. This discharge of electric charges, or lightning, causes light and intense bursts of heat and sound. You recognize the sound as thunder. Lightning is a massive electric discharge caused by static electricity. Believe it or not, this is the same type of energy that causes your clothes to stick together when they come out of the dryer. The electrons have been transferred in the clothes, so some clothes are negatively charged with excess electrons, and others are positively charged because they have lost their electrons. The law of electric charges causes them to stick together. Drag the balloon to Judith's hair to build an excess of electric charge on the balloon. The electrons are transferred from Judith's hair to the balloon. Watch how the electrons on the balloon attract the positive charges in Judith's hair. When the balloon is pulled from Judith's hair, there is a little electric discharge that is mostly heard as a crinkling noise. Now, build up static electricity and cause an electric discharge in the clouds. Drag the light cloud to the darker cloud to build up electric charge in the clouds. Lightning is a massive electric discharge, releasing enormous amounts of energy that can be deadly. As you saw with an electric discharge from lightning, massive amounts of energy can be released by static electricity. It is difficult to convert these short, intense bursts of energy into electricity that is convenient to use. Most electronic devices need a steady and continuous source of electric energy, called an electric current. An electric current is a continuous flow of electrons, whereas in static electricity, there is almost no flow of electrons within an object. In electric currents, the electrons of an object flow. Electric current is similar to water flowing through a stream, and static electricity is like a pond. Both a stream and a pond contain water, but how the water moves is different. In electric current and static electricity, both systems contain charges, but how the charges move is different.